Hello guys and welcome to Nessa tutorial today. So basically today we're going to be doing ECN 329. And what we want to focus on today is sequencing and scheduling. So let's call it S&S. And so I will explain just a little bit of sequencing and scheduling, just a bit of the backstory. But really, for that part, I would say it really helps to study your notes because sequencing and scheduling, the definitions and all those things in 3 to 9. Then the next thing that we'll do is we'll solve a question, and the one we'll be solving is the one that she gave us, that the lecturer gave us as an assignment. So we should all have those questions. Also, before we get into it, what I want to know is, do you want to continue doing topic by topic, or do you want us to do a past question or something like that? Just really let me know. So let's get right into it. So scheduling and sequencing. Scheduling is basically establishing the timing of the use of equipment. Scheduling, at what time are you going to use the equipment, the facility, the human, whatever it is that an organization has. And then basically sequencing on its own now has to do with the order in which these things are used. So you know that at this time this machine is going to do so and so jobs, but in what order is it going to take the jobs, that kind of thing. That's where sequencing comes in. So something important to know about sequencing and scheduling. So something that is important to know about these things is what we call priority rules. Priority rules help us to determine the order in which the jobs available in the system are going to be taken. So if you go to slots and you want your iPad fixed, how do they determine whose iPad gets fixed there? Obviously, maybe you met customers there. Some people have already dropped their iPads previously to be fixed. There's also going to be people who are coming after you to drop their iPads. How do they determine whose iPad to fix when? And that is where the priority rules come in. So you have what is called first come, first serve. You also have what's called, so this is first come, first serve. You also have what is called shortest processing time. So processing time has to do with how long it takes for them to do the job, right? And so if I bring my iPad to slots, the processing time is how long it's going to take for them to actually fix the iPad and everything they need to do to make sure that my iPad is ready to be given back to me. And so where it comes to first come, first serve, it means whoever brings their iPad first to slots gets their iPad back first. So it's first customer that comes gets served first. Shortest processing time, they're now looking whose iPad is going to take the least time to fix. And so that is the one they will do first. Then we also have what is called EDD, which is expected due date. So if I gave them my iPad, you gave them your iPad, Temitayo gave them her iPad, someone else gave their iPad, they will now look, when do these people need it back? If I said I need mine back in 2 days and you said you need yours back in 4 days, EDD says that they will do mine first because the due date is in 2 days' time, whereas the due date of yours is in 4 days' time. So EDD, expected due date, means they are doing it based on which due date is closer, they do that one first. So that's EDD. And the last priority rule that we have is called longest processing time. And basically, when it comes to longest processing time, there's also another one called critical ratio, but we've not done any we've not done any work on that, so I didn't think it was important to really speak on it. But longest processing time, basically, what it tells us, longest processing time basically tells us the one whose zone is going to take the longest to fix. If my iPad is going to take 7 days and your iPad is going to take 10 days, with longest processing time as their priority rule, they are going to fix yours first because it takes longer to process that job in their system. And so throughout this example, we're going to be using slots where you fix phones and computers and everything. I know they also buy phones there, but let's use the arm of them that fixes phones. So now, once you know your priority rules, the next thing that you really need to know are your formulas. And there are 4 important formulas for us to know that will tell us what we need to draw in our table and how we need to go from there. So the first formula is average flow time. So average flow time. Average flow time is how long is like, you know, the average of something. If you have 10, if you do 10 things in a day, the average of how long it takes you to do, the average of a set of numbers is the sum of the numbers divided by how many numbers they were. So let's not complicate too much, but let's get that off because this is now our actual formula. So average flow time, you're trying to know per one item or per one job in the system, how much time does it take for that job to move through the system? So I think here it's important for us to distinguish between flow time and processing time. Flow time is how long a job takes to move through the entire system. Both how long it takes to process it plus whatever else needs to, how long it takes to process it plus the waiting time, everything before it gets back to the final owner. Processing time is just how long it takes to work on that job, right? So your flow time, let's use slot as an example. The reason you have what is called flow time and processing time, if my iPad is going to take 4 days to be fixed, however, they are using first come, first serve, and there are 10 other iPads that need to be fixed, each of which will also take 4 days. And they're not going to get to mine until they finish fixing all those 10. And we said the 10 of them each take 4 days. So 10 times 4 means they are going to have 40 days of fixing iPads before they even get to my own, which will now take 4 days on its own. So the total processing time of fixing my iPad is actually just 4 days because that's how long they will spend working on it. But the total flow time of my iPad is however long it spends in the work center in the system, which is slots. And basically, it's going to wait for 40 days before being fixed for 4 days. So my flow time now becomes the processing time of every job before my own, which here is 40 days, which we can call my waiting time, because the processing time of every job before my own is the time my own will be waiting. So the waiting time, which is 40 days, plus the actual processing time, which is 4 days, means 44 days that my iPad is going to spend with slots before it finally comes out of the system, before it's finally given back to me. So that is what flow time is. This 44 days is the flow time. So that is what we take into consideration when we talk about flow time. Now, talking about processing time, like I explained, it's just the 4 days, however long it takes to work on it. So let's start a new sheet so I don't have to write over that in case you need to reflect it. So we were about to calculate average flow time. And with average flow time, like I said, the average of a set of numbers is the total sum of the numbers divided by however many numbers there are. So if you want to know the average flow time, that's the average time it takes each job to move through the system. you have to know the sum flow time of all the jobs in the system. I really hope you guys can see my handwriting. Sum flow time of all jobs divided by the number of jobs. So that gives you your average flow time. So if in slots they have 10 iPads to fix, and each iPad is going to take 5 days to move through the entire system, plus waiting time, plus fixing time, plus processing time. That means their total flow time for each iPad is 5 days, and they have 10 iPads in the system. It means that the total flow time for each iPad will be the sum of the flow time of one iPad plus one iPad plus one iPad. If iPad 1 is taking 5, iPad 2 is taking 5, iPad 3 is taking 5, all the way to iPad 10, which will take 5. That means you will add all their flow times to give you the total flow time, which will be 50. Right? So our total flow time for every job in the system is going to be 50, because that is the flow time of all the iPads combined. Then how you know the average flow time per iPad? So for each iPad, it takes an average of, you divide it by the number of items or the number of jobs, which is the number of iPads in slots, which will give you 5. All right, so let's get rid of this. And now let's talk about the next important formula, which is average number of jobs in the system. Say you don't actually know how many iPads that slot has to work on. An easy way to know it is to say, okay, how long does it take them to finish every single iPad they have in the system, divided by the total processing time of all the iPads. So you do sum of total flow time divided by total processing time. Pardon my handwriting, quite somehow. All right, so these formulas are formulas you need to know, because they will surely be your saving grace in the exam. So with 3 to 9, it's mostly knowing the definitions, the explanations, and then know your formulas. And so number 3, the next important formula which you will be asked to calculate in the question is average job lateness. So what this deals with is per job. Let's say, what is the average lateness? Like on an average, how late does slot submit each iPad? So if you need something in 4 days and they give it to you in 5 days, it is late. So to know this, what we need to do is total late days divided by number of jobs. So if slot has 10 iPads that are each due in 5 days, and on one iPad they were late 2 days, on the next iPad they were late 3 days. Let's say for all of them they were late 3 days, just for easy calculation. Let's say for all of them they were late by 2 days for easy calculation, right? So for each of these 10 iPads, instead of submitting on the 5th day, they submitted it on the 7th day, meaning they were late by 2 days. To now know the average lateness, you take the total of all the lateness, which will be 2 in 10 places, which gives us 20, divided by how many iPads there were, which gives us 10, which gives you your average lateness. So on average, per iPad, not submit 2 days late. And so you can calculate this for the question at hand. Moving on, let's talk about number 4, the next formula, which is utilization of work center. Utilization of work center equals to total processing time divided by sum of total flow time. Total amount of time they spend working on the things divided by the total time it takes them to move everything out of the system times 100, because your utilization of work center is a percentage figure. So with this bad handwriting, let's move on to the question. So let's carefully take a look. Assuming 8 jobs are waiting to be processed, the processing time and due dates for the jobs are given below. Determine the sequence processing according to first come, first serve. So they've given us these 4 priority rules that we should use them to calculate the following. And you'll soon see the difference between using one priority rule and using the next. So let's go and look at our table. So for the purpose of this, you're going to want to copy out your table into your solution as well. So for this purpose, I'm just going to literally, I hope you guys can see what I'm doing here, because we're going to do the solution here. So once you copy this out, you literally actually only have 2 things to add. And the 2 things that we have to add are, the first thing we're going to need to calculate, if you notice from all our formulas, the first thing we needed to calculate was flow time. Let's call it flow T because the space is quite small. So in our formulas, right, another thing that was really prominent is the use of flow time. But another thing that was prominent in our formula was the use of late days. So those are the 2 things that we used in our formulas that were not given. And so from here, let's all right, so these are 2 things that we need in our formulas that were not given to us: flow time and late days. And I'm going to show you now how to calculate both of them before you even move into the next thing. But before I do, it is worth mentioning that the way the table is arranged already is automatically your first come, first serve, because it is arranged according to how the jobs were given. However, in another scenario, in another way, you would have to rearrange this table. And let's use shortest processing time, for instance. Shortest processing time looks at this, the processing time. And it's trying to tell us that however the processing time are, the ones with the shortest processing time will be handled first. So A would still remain at the top of the table, as this line would still remain at the top of the table. However, the next one will not be B, because the next shortest processing time is 8, which belongs to E. So E will become number 2 on the table. Then B with 9 will become number 3 on the table. So this whole row, the entire row of B will move to number 3. E will become number 2, the second row. So the arrangement would go A, E, E, 6, E is 8, B is 9, 10, for E, that's 24, and for B, that's 16. So the whole row, and then we'll still calculate our flow time, our late days. Let's do one more. So the next shortest after B is what? 13, which is C, coincidentally. So C is 13, and its due date is 6. So this is for shortest processing time. If we were to continue, we would continue with the next shortest, which is 15D, followed by 17F, followed by 20G and 22, which belongs to H. So if we were to be doing shortest processing time right now, that is what we'll be doing. I would still do the flow time and the late days for that one as well. So quickly, moving into calculating your flow time. Your flow time, remember when we said that your flow time has to do with how long it takes them to move your job through the system, how long it takes slots to, whether it's waiting, whether it is being worked on, the waiting time or plus the working time or however long it spends with slots is the entire flow time. And so remember that when your iPad is waiting, what happens is that they are working on the ones that came before you. So in a first come, first serve, let's say you were customer C for slots. Sorry, customer G, this is us. We are customer G for slots, right? It means that they are going to work on A, B, C, D, E, F, G before our own. And the shortest processing time, okay, let's actually change who we are. We are not customer G. Let's say we're customer C. This is us. And so that means they're going to work on customer A and customer B before us. However, in the shortest processing time method, they will work on customer A, customer E, customer B before us. So our entire flow time in the first come, first serve, we'll look at the processing time, the time it will take them to finish working on customer A, B, C, before customer A and B, before they get to us, customer C. So for customer A, the flow time is just 6 because there is nobody before customer A. For customer B, the flow time is 9 plus the processing time of customer A, which is 6 plus 9, which will give us 15. For customer C, which is now us, however long it took them to do customer A and B, plus our own will give us our flow time, which is 6 plus 9 plus 13. Or you can just say 15 plus 13 because it's already calculated 6 plus 9. So 15 plus 13 will give you 28, right? And then 28 plus 15, like that. I think, I don't remember what. Well, wow, I don't remember what 28 plus 15 is. That's 38 plus 5. So I think that's 43. Correct me if I'm wrong, because I've been out of school for a while. Well, I'm online school, but you know what I mean. Then 43 plus 8, you keep going like that. Now, how do we calculate the late days? We have to, okay, let's calculate the flow time for the shortest processing time. So for here, the flow time will change because before customer E is customer A, which is 6. 6 plus, for customer A will still remain 6 as flow time. For customer E, it would be 6 plus 8, which would give 14. For customer B, it will be 14 plus 9, which would give 23. And for us, customer C, it will be 23 plus 13, which would give 36. So as you can see, if they were using first come, first serve, the total time that we as customer C, remember our customer C, would have waited would just be 28 weeks, I guess it's weeks, 28 weeks before they give us our iPad. But because they are now using shortest processing time, before they give us our iPad, it would take 36 weeks. So that is why it's important. If you were using longest processing time, you would arrange this thing based on how long the processing time is, and the longest one will go to the top, the shortest one being the last. So it's from longest to shortest. If they were using expected due date, they would be using the one with the earliest due date here. So here, that would be C because C is 6 for due date. So that's just basically how it goes. But the formulas and everything you're calculating is the same. It's just that your flow time, your late days, and everything, the way it's arranged, will give you different figures. So let's keep going. How do we calculate late days? Remember, I said if you need your iPad in 7 days and they give it to you in 9 days, they are late by 2 days. So late days is actually flow time minus due date. Due date was 10 weeks and they took 6 weeks. Due date was 10 weeks for A and they took 6 weeks for it to move through their entire system, both waiting for them to finish whatever job, which was no job before A, and the processing time of A. So the late days will be 10, 6, which is your flow time, minus 10, which will give you -4, meaning they were actually early by 4 days. However, when calculating late days, we do not consider negative figures because they were not actually late. So we will put 0 right here. If you didn't get what I said, please go back, listen to it slowly. I'm so sorry I'm talking so fast. Then, when it comes to this next job, job B, if we needed job B in 16 weeks time, and the total flow time, the total time is spent, we needed it in 16 weeks time, and the total time is spent in their system was 15 weeks. So they are not late, they were actually early by 1 week. So we put 0 because we don't do negative figures. 15 minus 16 is -1, so we put 0. Here, the total flow time was 28, and we needed it in 6 weeks. Remember, this is us, customer C. We wanted our iPad in 6 weeks, right here, 6 weeks. And they gave it to us in 28 days, in 28 weeks, because they were processing A and B before our own. So we waited some time. And then, so in total, our flow time was 28 weeks. 28 minus that 6 that we needed it would give you 22. So that's the late days for us. For customer D, 43 minus the 9 weeks that he needed it would give us 43 minus 3, 40, 40 minus 6, 24, 34. Wow, 34. So like that, you calculate from E to H for the flow time and the late days, and you total it. So one thing that is important here is our total. So our flow time, from having worked on this before, the total would have given us 110. Our late days, I'm not even sure again. Your flow time, the total would have given us 409. For late days, for processing time, the total would have given us 110. And how you know this flow time, your flow time column is correct, is when the last flow time you have, which here will be 110, is equal to the total processing time. So that's a way to check that and make sure that is correct. And so moving on from there, you also have to total your late days, which from working on this before, I know that total late days will give us, sorry for that interruption. From working on this before, I know that total late days will give us 113. Or was it 133? Pardon me. It's actually 133. And so we can now apply these figures to our formula. Remember, you will calculate your flow time for your SPT, for your late days, and your late days for SPT, and total everything. So they will be different for each priority rule that you use. That is why in this assignment, I'm probably sure they wanted us to see that your answers differ for every priority rule you use. But let's take these figures down. I'm going to write them down. So our processing time for first come, first serve, since that's the one we are doing now. The total processing time for first come, first serve is 110. The total flow time for first come, first serve is 409. And the total late days for first come, first serve is 133, as well as the total number of jobs, as you can see. So the total number of jobs, as you can see, based on A, B, C, D, E, F, G, H. H is 8, so we have 8. So let's move that back to our whiteboard, where we have our formulas. And these are the 4 things we're asked to calculate. So let's take number 1. Let's go back to where I wrote flow time that time. All right, let's take the first formula, average flow time. If you remember the formula, remember it was sum of total flow time divided by number of jobs. So this is for first come, first serve priority rule. Remember, your answers will be different depending on how you arrange the jobs that you're taking. Remember how when we were using first come, first serve, it took them less time to give us back our iPad. That's the flow time. It took them less time to finish our iPad than it did when they were using shortest processing time, because shortest processing time, there were now 4 customers above us with and by the time they calculated their own processing time, it took time for us before they got to us. But with first come first serve, there were only 2 customers above us and it took less time before they got to us. So your answers will be different for each formula you use. So sum of total flow time gave us 409, and we know that there are 8 jobs. By the time we divide that, we have, let me consult my calculator. 409 divided by 8 is 51.125. So let's take the next one, 8, which is average number of jobs in the system. So remember, this is still for first come, first serve. Average number of jobs in the system. Pardon my handwriting. And that's sum of total flow time all over total processing time. So remember that our sum of total flow time gave us 409, and our total processing, sum of total flow time gave us 409, and our total processing time was 110 for all jobs, which gave us so on an average, there are 4.454 if we want to approximate. Sorry, if we want to approximate, that will actually be 4.455. But let's leave it as 4.45, just because. So I would say be consistent with your approximations. Here we did 51.125. So let's change this to 51.13 so that we have the same 2 decimal places in each answer. So on an average, at any given time, on an average, there's 4.45 jobs in slots. They have at least on an average 4.45 iPads to fit. Okay, so it doesn't mean this is how many they currently have. It's just like the average. When you take an average, on average, they have 4.45 iPads with them or jobs that they have to do. So the next is average job lateness. Always keeping in mind that this is for first come, first serve. So remember that when you finish calculating for first come, first serve, you have to go and draw your table again, and then calculate flow time, calculate late days, and then come and use their summations and everything in these formulas again for each of the priority rules, shortest processing time, longest processing time, EDD as well. So number 3, average job lateness, right? Average job lateness. So total late days divided by number of jobs. So our total late days, by the time we calculated, you remember, it gave us 133 divided by 8 jobs that are in the system. Let's consult the calculator. That gave us 16.625. Hope I'm not missing anything. Remember, we were approximating, so that's 16.3. So I must apologize. We're using the wrong figure. Our total late days, actually, by the time you calculate it, would actually not give you 133. That's actually the total due date. The total late days would actually give us 281. So I solved this before, so I went to check and I mistakenly took the wrong figure. So like I said, it's actually meant to be 281. I apologize for any so it's 281 divided by 8. I need to figure it off. So 281 divided by 8 will give us 35.125, which are approximating to 35.13. So the next thing that we're supposed to do is to calculate the utilization of work center, which is the last one. Pardon my handwriting, I'm still getting used to this. On paper, it looks a lot better, although not good, but still better. Work center utilization. Remember, this is first come, first serve. So you do this all over again with your table and everything. Utilization of work center gives us total processing time over sum of total flow time over sum of total flow time. Then this whole thing that you calculate here times 100. So that will be our total processing time, if we remember, was 110, and our total flow time was 409 times 100, which will give us consult the calculator. 110 divided by 409 gave us 0. Let's approximate to 3 decimal place, 0.269. And if you times that by 100, you get 26.89. So this is basically the answer to the entire thing. So what you will now need to do, let's give an example, is to take your table and draw it again from scratch. And so you would have jobs. Let's say this way for short, no, I've already used, oops. So I've already used shortest processing time to do an example. Let's use ED, expected ED. So you would have, I'm not going to solve it from up to the formula part, but I'm going to just show you the rearrangement. You would have jobs, you would have processing time, you would have due date. You would also have, so these are the parts we're adding ourselves, right? So we're adding this part ourselves, which is our flow time and our late days. Then what you would do would be to arrange this based on the expected due dates. So if I can show you the question again. I don't know why it is appearing like this. It's Zoom's fault. But as you can see, this is our due dates. And so we want to take the shortest one first, which is 6, and that belongs to C. So we have C 13.6, first of all. The second one would be D, which has 9 as the due date. So it will be B 15.9 as the second row. So C 13.6, B 15.9. Let's go back to C 13.6, B 15.9. And then like that until the end. So you just keep going until the one with the longest due date or the farthest due date. And then you calculate your flow time. Flow time for this will be 13. And as you can see, if they were using this method, remember we were customer C, they would have attended to us first. And if they would have actually attended to us first. And then for C, did I no, I didn't. So then for D, your flow time would be 13 plus 15, which would be 28. your late days would be the flow time minus the due date. 13 minus 6 is so whether or not they attended course fresh, they would have still been late. So 13 minus 6 would give you 7, maybe. 28 minus 9 would give you wow, I'm not 28 minus 8 is 20 minus 1, 19. This is embarrassing. But so that is basically how you do for your earliest due date. And with that, I want to say thank you for watching. Terrible. Please leave questions in the comments. Questions, suggestions, and tutorial requests. In the comments for 300 level students that might have watched this. Do you want us to keep going topic by topic for 328, for 329? And how do you want us to go about 328? What do you need to see? What do you want to see? So, bye. Thank you for watching Nessa's Nessa tutorial ECN 329 sequencing and scheduling.